All right, another talk on routing leaks. This one I think is different enough that you might find this interesting. So this is a talk titled Visualizing Routing Leaks in three dimensions. No glasses needed. So I'm Doug Midori from Oracle, and I'm going to talk a little about how I think about some of these routing incidents and how we can maybe better communicate them, because I think there's some limitations in how we speak about them. And in full disclosure, this is as much a self-criticism as it is criticism of anyone else. I too have written a lot about routing leaks over the years, and I use the same kind of shorthand to talk about the scale of these routing leaks using prefix count, as we see like in these two incidents here. So this is the thing on the left here. Is a screenshot from some coverage of the Allegheny Networks Verizon routing leak that affected Cloudflare. We've heard about that a couple times now. The one on the left, the SafeHost, the China Telecom routing leak, we heard from Luca. In the coverage, we see that these, the way we talk about these routing leaks is that we've got numbers of prefixes. So the one on the left is more than 20,000 prefixes. The one on the right is more than 70,000. I guess I'm here to say that these are just, there's some weaknesses in these numbers that we want to have to come up with a way to do this better, to communicate some of the nuances that are evident in the propagation of these routing leaks. So here are the weaknesses. For one, when we talk about these single one-dimensional metrics, not every leak is propagated to the same number of ASs across the internet. Not every leak is in circulation the same amount of time. In fact, in every one of these incidents, many of the leaks actually don't propagate very far, and many of them don't last very long, and yet are added to this prefix count list and serve to either, one could argue, to inflate the number, or even just make it kind of almost to a certain extent meaningless. And as we'll see in some of these visualizations, we see that there's always like a very long tail for prefixes that don't go very far, and I think at an internet level, this is internet level analysis, we can argue that most of those prefixes had negligible impact, operational impact on the internet. So there's got to be a better way. So what I propose in this analysis technique is to integrate these other dimensions of duration and propagation into how we think about routing leaks, or it could be even any kind of large routing incident. Today, the topic is about leaks specifically. So in these three dimensions, we've got a dimension of just the set of prefixes that got touched to any extent, just to have them in one axis, sorted by how much propagation, kind of like the high water mark of propagation for each of these prefixes. Another axis is time, we kind of know how that works. And then the last is propagation, and the way we assess propagation is look at our hundreds of BGP sources and figure out what's the percentage of our sources that picked up the route, the leaked version of the route at that time. And so then, if we followed that explanation, then if there was a routing leak that somehow achieved total global route propagation during the period of the leak for all the prefixes, then you'd have a solid block. But that never takes place. In fact, this is the visualization of our analysis of the Allegheny to Verizon leak that was touched on in the previous two talks. And I hope you'll agree with me that there's a lot to be said for trying to look at it in this perspective to understand where is the impact here in this routing leak, because where the reporting and the previous analyses, we talk about tens of thousands of prefixes. When we look at what were the prefixes that got propagated pretty far, it was really just a few hundred, and it was arguably maybe just 1% or so of the total set caused the problems. And that's where we ought to focus our attention to make sure we're focusing on the right thing to clean this kind of behavior up. So after this incident, there was a lot of discussion around how RPKI could have assisted here, and I don't disagree. I'm on board. But I think it's worth running the numbers just to make sure we know, we're honest to ourselves, what precisely would that have done for us? Out of this leak of about 29,000 prefixes, the vast majority would have been RPKI unknown. We're still working on trying to get more ROAs created. That's an ongoing issue. There's a lot of progress made, but we are where we are. The next highest category would have been valid. So one thing that's important to note in this incident that was exacerbated by the use of a route optimizer, a leak from a route optimizer preserves the origin in the AS path. So you're not going to have a new origin, or that's not going to be it's not going to be an invalid ASN due to the route optimizer. So there actually was many more RPKI valid routes than there were invalid. And then for the two different invalid categories, this invalid length, that's really where RPKI could have done a lot of good. We'll mention that in a second. And the last category is invalid ASNs. And I just said that the route optimizer doesn't change the origin in the AS path. These are just routes that are invalid all the time. They are misconfigured ROAs that are always, anytime they cross somebody who's going to drop an invalid, they are going to be classified as an invalid ASN. These just, unfortunately, there's some number of these that always exist. So back to the invalid length. Martin gave the talk about it earlier about how Cloudflare got affected by this. And Cloudflare would have been, had these routes been dropped, they would have been spared, and maybe we wouldn't all be talking about this. The only reason that is true is because of the max prefix length set on those ROAs. So that's an important point if you're hoping to use RPKI to defend yourself against this kind of a leak. You're going to have that max prefix length set as an exact match of the route you're trying to protect, because if it's one bit more, then a route optimizer has got room to insert a more specific, and it did you no good. So I've written a number of these over the years, over the past decade, of autopsies or after actions about these routing incidents from my time at Renesys and then Dyn Research, and now it's Oracle Internet Intelligence. And it can be a little bit formulaic. So it's how many prefixes were involved, what were the ASs, when did it start, when did it end, and then some highlights of what were the impacts. And I guess having done this for a while, I decided there's probably a way we could just automate this, honestly, because you could script this out and it would pass on the same amount of information. I also, from people who know me, often people will reach out to me directly and say, hey, what were the prefixes involved here, and what were the extent of the impact for them? And so I'll run something, but this doesn't scale. The email doesn't scale. Not everybody can be my friend. And so this is a way that we can kind of communicate an autopsy of one of these incidents in an automated way that's consistent across different events. And I hope it's informative, and I hope it's kind of a new way to look at these types of events. So we've gone back and done about 100 events in the last few years, generated these interactive three-dimensional visualizations. And the criteria was a little bit arbitrary. It needed to be more than about 100 prefixes involved, unless it was like really noteworthy. And about 10% of our BGP sources, because otherwise there is a lot of low-lying noise that we don't want to. We want to try to come up with things that had some sort of potential impact for disruption. And then we intend to add more going back in the past, and then invariably when there's more incidents into the future, we want to have this to be a place where there's been an incident. Instead of people trying to email Doug, maybe there's a place that we can automate this analysis and then publish this as soon as we can. I can't guarantee this is within minutes of the incident, but we hope to do that in a timely manner. That's the vision. All right, so if you're on this site, then here's just a quick walkthrough of the features. So we're trying to be able to slice and dice or decompose one of these incidents to try to understand what were the origins of the routes that were impacted, what were the geography of the countries, because that ends up being a topic of discussion. And I'd like to have a more informed discussion around where the impacts were and where they kind of were not. Another concept here is this idea of impact. And impact here, we're just strictly looking at aggregate propagation, or as measured as just the area or the volume under this surface, the area under the curve. And that just serves as a way of just trying to figure out how much propagation in total did one incident exhibit versus another. And if we have those methodologies be consistent, then we can kind of compare from one incident to another and figure out what had more propagation in total, what was a bigger BGP incident. So with those tools, then we can go back and revisit things in the past. This is a kind of a pet peeve of mine, is this China Telecom incident from 2010. It's almost 10 years ago. And so there was a bunch of coverage along these lines of, China swallowed 15% of the internet. And in this body in NANOG, I know when these headlines came out, people kind of like, poo-pooed this because this is kind of ridiculous on a lot of levels. And I thought for a long time this was kind of put to bed, but honestly, if you look in national security, U.S. national security writing, this is still quoted as, a fact. And I feel like it's worth revisiting now that we have this a different approach and just really poke some holes into this. So for one, obviously the biggest issue is routes don't equal traffic. I think that's we can agree on that. But let's just say routes equal traffic, or maybe the headline was 15% of the routes were taken over or totaled for 18 minutes. Somehow try to make that a little more correct. It's still not an accurate assessment. So in this case, if this were true, that 15% of the routes, it was about 50,000 routes, so that was 15%. It was a little more than 300,000 routes at the time. These were totally hijacked, then they would have to be 100% global propagation unless we're going to start discounting in that dimension as well. And so you need to have, like we mentioned earlier, some sort of like solid block of propagation. In reality, it wasn't anywhere close. And if we were to run the data through this analysis, we can see that there's there's a very common pattern here of this long tail of a minority of a fraction of prefixes that get propagated very far, and then a long tail that get touched that don't go very far or don't last that long. If you break this into by country, we can see that the impact actually was far greater on other Chinese routes than they were on US routes, which is what people still get bent out of shape about. In fact, on this table on the left, this is from the site, we kind of have this absolute impact. That's the area under the curve. So the Chinese routes accounted for 74% of the total propagation. And so the vast majority of it was just self-inflicted. That's for 11,000 routes, about 16,000 routes for US, and they only accounted for about 8% of the total aggregation, or total propagation. This total curve was only about 4.6% of the total theoretical max. So what was the total box that this three-dimensional space would have taken up? It's only about 4.6%. That's how much it takes up. So if we were to add all these discounts in, we're talking about 0.07% of route propagation. It ends up getting pretty small if we're just focusing on the US portion. The only exception to this are a handful of US prefixes that were widely, the leaked versions were widely propagated, and that was a result of heavy prepending of these ASs. They had kind of basically set themselves up for hijacking. They had a single upstream that they had heavily prepended to, and when the leaker came along, most of the internet believed the leaker because the legitimate origin had a ridiculously long AS path. So here's a couple other incidents that we can go back and look at. So this is the Indosat leak of hundreds of thousands of routes back in 2014. When in reality, it's a bit more bimodal, right? There's one set of maybe about 8,000 prefixes that went everywhere, and then an extremely long tail that went almost nowhere. So if we were to communicate this type of incident, we don't want to have a single metric to convey this, because it's you're going to assume these are all equally impacted, when in reality, it's probably more accurate to call this an 8,000 prefix routing leak versus a 487,000 prefix routing leak. If we compare that to the following year, we had another very large-scale routing leak. This was Telekom Malaysia. This one is a little bit bigger, and so the difference is, if we look at that, they compare the absolute impacts, the areas under the curves. This Telekom Malaysia leak from 2015 was involved half as many prefixes, but had 6 times as much aggregate propagation. Because this was, you can see it visually that this curve has got a lot more meat to it. That was a more impactful incident. So from running through a bunch of these, I've got a few observations that I can make. So where the problems exist are in these leaks, or basically what are the prefixes that were widely propagated. So why do these small sets of prefixes get widely propagated? There's typically one of these 3 reasons. There's a more specific of an existing route. Either this is generated by a route optimizer, as we heard in the previous talks, or also these come from traffic engineering. And so if there's a routing leak and there's a lot of more specifics, it doesn't automatically mean a route optimizer was involved. If you recall the level 3 leak from November 2017, this was a case where companies like Comcast and Bell Canada were announcing a lot of more specifics into level 3 that try to influence return path traffic. When that leaked out and added tens of thousands of more specifics into the global routing table, no route optimizer was involved, yet that was what was the most damaging part of that incident. Another type of route that seems to cause problems are these regional routes, or routes that have intentionally limited their propagation. In the case of the SafePost routing leak that Luca talked about, that went through China Telecom, the European mobile carriers that got whacked there, the reason why they really got whacked was that they limit the propagation of their routes to Western Europe. They announced more specifics and then just to parts of Western Europe. When the leaker starts announcing these to the rest of the internet, there's nothing for that route to contend with, and it just fills in the void and it takes over, and then it causes damage. So it's something to consider. If you've got that as part of your routing strategy, consider what happens when a routing leak occurs and the rest of the internet starts to use this more specific that you've announced just to a part of the internet. And then, I've got a new foot stomper here that I do on excessive prepending in any of these cases, any of these leaks that we've talked about today, the old ones, the Indosat and Telekom Malaysia, on up to the Allegheny Networks and Verizon. Some of these routes that get propagated the farthest by route optimizers are due to excessive prepending that basically serves no purpose, but just adds risk to the legitimate origin. So to wrap up here, I hope I made my case that I think the dimensions of propagation and duration would improve if we can add these into the discussion of routing links. Would improve our understanding of how these things take place and how they actually disrupt traffic. We need a better metric than just simple prefix count. And like I said, I'm as guilty as anybody. I've been writing about these for a long time. I'm in here in part to absolve myself of sins. And now, what's the suggestion? We can come up with something like it's got to be more than 1% of peering sources or greater than 10 BGP sources. Not all of us use the same data, so that makes it problematic to come up with a common percentage threshold. A more esoteric suggestion would be to could we make use of this area under the curve as a stand-in for a Richter scale of just aggregate impact. That would be kind of neat, but it is a little bit kind of hard to get your mind around some of these pinball numbers of just how big one of these incidences. I'm totally on board with RPKI would do a lot to try to contain these incidents. Obviously, they're going to continue to happen as humans make mistakes on routers. I would check your max prefix length, and if you've got if you can set it to be an exact match, you might want to consider doing that, because it may save you once we have more networks dropping invalids in the event of a route optimizer leak. And so we're hoping this type of analysis. We've published this. Now it's a live site with lots of things you can download out of it. If there's anything missing or you have any questions, feel free to reach out to me. And if you see anybody saying China Telecom hijacked 15% of the internet, please send them my way, and I'll set them straight. All right. Thanks a lot.
Hi.
Hi.
Doug Montgomery. Your percentage of peers are strictly the percentage of peers that your collectors talk to.
That's right, yeah.
It's not the ASs in the path downstream of the leak,
No.
which are also affected?
Yeah, you could. We're using I'm trying to think what would be.
So it is a function of who you peer with for collecting, right? I mean,
It is, yeah.
Right. And what about a metric that looks at the number of routes that pass through those points?
The number of routes that pass through the points. Which points?
The points that have been affected by the hijack, right?
The BGP sources, or what's the point?
Well, it kind of gets to the point of the impact on, where the ASs who have accepted the leak are, right? And how many routes to those destinations pass through them?
I don't think I'm following the question. I'm sorry. How many routes that normally pass through them to get to?
Right. Well, let's say that I'm affected by the leak, right? I believe the leak, but there are very few routes that pass towards that destination through me, right? I mean, it's sort of a different dimension of impact.
I guess maybe that'd be a reason why I wouldn't use an intermediate AS. So the BGP sources we're using for that peer percentage, those are all full tables. So they all can be guaranteed, with some caveats, that they're going to carry those routes. And so then if you were to start getting into intermediate hops or intermediate ASs, then maybe they weren't normally on the path. So maybe that's an argument for using the BGP sources that have full tables. But all right. Yes.
Hi. Did you look at sort of delta integral numerically or visually on a what if everyone was doing origin validation, or in the glorious future world where I think there is an RFC on path validation, but we're actually doing it, how that would change? So separating the more specifics and whether you mark your covering, but just for the same specificity.
I think it would be neat to draw two pictures. One is what happened and what could be.
Right.
That would be, but I haven't done that, but there would be value in that, yeah.
Okay. And we're happy to take a look at adding traffic density to some of this stuff too, so we could look at not just number of routes, but actually, sort of traffic affected.
But that would be great, because there's one, obviously, a huge assumption here is any kind of large-scale BGP analysis like this is you're assuming all prefixes are the same. Mm-hmm. You're assuming all ASs are the same. Obviously, those are not true, but BGP inherently doesn't know and tell the difference. Having some sort of notion of traffic would be a stronger mechanism for teasing out impact.
Because we all learned during AS 7007, which is for sale right now, by the way, to put your name servers and things like that in the first/24 of any natural site thing. So.
Thanks. Yes.
David Paul Zimmerman, LinkedIn. My photographic, or lack thereof, memory, I'm trying to keep all the different 3D graphs that you had up there in my head, and they're all.
I'm happy to go back to one.
Maybe a couple. What I think I noticed was that a lot of them, that they had that waterfall effect over time, but the time element seemed to be kind of binary. The event was happening or it was not happening.
How about this one?
Yeah, that's a great example. So I'm looking at the time axis, and it all kind of falls off at that one time, and you don't get much after that.
Yeah.
And I kind of remember most of the graphs kind of being like that, where you've got two axes, which are amazing information, and one which is kind of, it's helpful. So where I'm going to is, I was wondering if you had any thoughts about other data that you could represent along that axis.
Which is the axis you find not helpful?
The time one, where you've got kind of that hard
time, okay.
That you've got that hard line. You've got this, you show the fall off of the actual impact of the prefixes, and you've got the kind of this hard line about halfway down where at time X,
it's over.
Yeah, it's over. And so it ends up being kind of binary, where if you replace that with another kind of datum.
Okay. I guess
you thought about that.
I don't think these examples in this talk, there's good examples of where time is helpful, but they exist of times where there's kind of different phases through time, or there's some sort of like oscillation going on, and I think having a time dimension is helpful to understand state as it goes through time.
Where the graph shows like it's improving, and then it like doubles down and gets worse again.
Yeah, so I would want to be able to capture that, because I feel like one of the weaknesses, again, for our stuff in the past as well, is this is an evolving three-dimensional thing as it goes through time. Maybe this one has got kind of like I mean, there's a little bit of dimensionality, but so it's consistent, but yeah, there's other examples of times where there's one state, and then it's another state, maybe it's going on and off. And then time would be helpful to know, so you're going to suggest another axis, though. What was that?
Well, no, I wasn't. I was suggesting if there was another way of showing time and replacing that axis with something. I was getting to, have you thought about other data you might replace that axis with? That is
something. Somebody's volunteering for offer up some flow data, probably. I don't know.
Maybe. Yeah.
That would be great. Yeah. All right. Thanks.
Thank you.
All right. Thanks a lot.